star, the star changes in brightness and appears to move. And the idea here is if you have a nearby companion star that's brighter, you can use instrumentation to look at the bright star and actually measure what the atmosphere is doing and correct it at a rate fast enough that the dim star now becomes visible. Some of you may own Bose noise-canceling headphones, similar kind of scheme, where the headphone has microphones listening to the room noise, and it injects noise at the right time and the right properties to cancel out that noise. So you hear, if you're on an airplane, you don't hear the jet engines as much. It's a dramatic thing the first time you put it on. So here's what we get from this adaptive optic. With the adaptive optics off, you just see a smudge. Here is an example. You turn on the adaptive optic, so now the adaptive optic is looking at a bright object. And that bright object is hinting at what the atmosphere is doing, and you make the appropriate correction in this optical stuff here. So here's a distorted star, and we have here a deformable mirror. In some of them, they look kind of like a pizza pan. So it's a high-performance mirror, but it's very thin, and it has hundreds of actuators behind it, pushing under computer control to correct for the atmospheric jiggle. And so instead of seeing the smudge, you see this. It's actually a binary star system. And this was a big success. I think originally it was designed so you could image space objects. And in fact, you can look around for examples of this on the internet of pictures of the space shuttle flying by when they have adaptive optics turned on. Without the adaptive optics, you just see a smudge moving across the sky. With it on, you see everything. Here's another example, with and without adaptive optics. And here's Jupiter, lightning storms on Jupiter. Now, next comes another advance. What happens if you're looking at a dim star and there's no bright star nearby to help you measure the properties of the atmosphere? Now we have to make our own star. We call it synthetic guide star. And here's the science behind it. The atmosphere is constantly bombarded by meteors. Some of them become meteorites, which actually are visible or might even hit the ground. But meteors are just hundreds or thousands of tons of debris from the solar system is falling on the atmosphere all the time. At the very highest levels of the atmosphere, there's a constantly replenished supply of sodium, iron, indium. There are various things that are in meteor dust. And sodium, if you poke it the right way, it will giggle. You shine a light source up to it and stimulate a behavior in the sodium atoms, and they glow. It's called fluorescence. So this next advance is that these telescopes have laser systems built in that don't interfere with the science, but they can stimulate a synthetic guide star at an altitude of, say, 100 kilometers above the telescope. Now we don't need a bright star to help us measure the atmosphere. The synthetic guide star does that for us. And the more advanced systems actually create a guide star, say, at 100 kilometers, and another one at 60 kilometers, and another one at 30 kilometers, so you can actually get the profile of atmospheric disturbance and take it out using this mechanism is the same, that is a computer changing the shape of a piece in the telescope. So synthetic guide stars were the next big advance, and they're all over the place. Every major telescope these days has synthetic guide stars. So it's not meant to say that this light is going to that spot that's the Milky Way, the belt of the Milky Way. The light never gets there. It gets absorbed in the upper atmosphere. Here is pictures from a patent that my student and I developed, where we did an advance in synthetic guide stars. And after arm wrestling with patent attorneys and our company, we managed to patent our advance of this to improve the way this is done. I have seen no money from this. Not one dime. And I think actually the company let this expire. You have to, every 17 years you have to pay $2,000 to re-up the. Someday this will make me famous, but I won't be alive. Okay, so now, somebody asked about practical applications and so forth. Not Doppler shift so much, but this ability to modify optical beams based on manipulating a deformable mirror, yeah, it has an application. That is a human eye. And various kinds of technology here. So now, this is commercial product used by ophthalmologists to measure the defect in people's vision in real time while they're doing, for example, LASIK or whatever the modern version of LASIK is. And every part of this medical machine has a corresponding part to this drawing, which is from my patent, that you have the deformable mirror here and here, and you have a corrected wavefront that results, and you have a retinal camera to measure the defect that you're trying to remove. So while the machine is running, you're driving the defect in the person's eye down to 0. So practical application there. So now let's talk about VLT. This is the Very Large Telescope, a product of the European Southern Observatory. Oh, a typo, sorry. And the VLT is interesting because it has 4 identical 8-meter telescopes. Here they are. Each one of these is the size of this building. And out there somewhere, this is Chile, out there somewhere is the ocean. Literally, Chile is that narrow. You can see the ocean. Some of you may have been here. This is in the desert where the seeing is good. The humidity is low, they rarely have cloud cover, and it's pretty high altitude. 11,000 feet, I'm guessing. So the reason I'm excited about this is I worked on this. When I joined Ball in '93, they already had a contract to design a performance model for this telescope. This is called the unit telescope, and they were building 4 of them. 4 identical units. And you should see the price drop and the performance improvement between the first one and the subsequent ones. Dramatic drop in the production price of the big mirror and a dramatic increase in the performance of those mirrors. So my group, from '93 till '97, we built a computer-based simulation of the performance of this device in a way that was independent of what the Europeans had been doing. They had a team of people, maybe 30 designers, who had built models of different things. Because remember, we have involved in this, you have optics, you have structures, you have materials, you have aerodynamics, you have seismics, you have thermal, there's all different kind of disciplines involved. Our challenge was to build a single computer model that integrated all of that. And we eventually did. It took a lot of trips to Munich to work with their engineers. But the idea was, how is this thing going to perform? And so we worked on this till like '97. They went through commissioning maybe 2001, and it's a highly productive facility. Now, there's something unique about this too. These aren't just randomly placed here on this mountaintop. These individual telescopes can look at 4 different objects on a particular night, or they can all be used together to look at one object and build what is called an interferometer. And to complement the interferometer, this is what I'm about to show you. These white lines show you, hard to see, but there's a little mirror here, and here, and here. So by building an array of independent telescopes and focusing them all on the same object, we can simulate a telescope the size of the mountaintop here. And this is called sparse aperture interferometry. Sparse meaning it's not one big piece of glass. There are a lot of holes in the glass. But together, with proper processing of the data, you get the simulation of a giant telescope. Now, we've already talked, here's VLT again. Here are the 4 big telescopes, and you can see the auxiliary telescopes. This is a photograph of the summit of Paranal. Once again, high, dry view of the southern sky. You have the 4 8-meter telescopes, and then these complementary telescopes. And together they build something called an interferometer. Interferometer is not too different than what you might have seen if you go to New Mexico and you see the very large array out in the desert. It looks like a bunch of mushrooms. They're all radio telescopes, and they simulate the performance of a ginormous radio telescope by having a whole bunch of them spread out on the desert. Here's Mauna Kea. The reason I'm showing this now is here are the 2 Keck telescopes. These 2 are identical. And between them are smaller telescopes that produce an interferometer. So the Keck can produce a telescope, an interferometric thing. That's about, I think, 80 meters if you turn it into an interferometer for an evening. And there's other stuff up here. There's smaller telescopes. There's Subaru and Gemini and some smaller facilities. Last time I was up there, I was living at an altitude of 9,000 feet in Gilpin County. So we got on the bus to go up for the tour of the summit, and the driver said, well, we've arrived at the astronomer's dormitory. It's at 9,000 feet. We're going to have lunch here. It was like 11:15. So everybody's like, why are we having lunch so early? So I talked to the driver. He said, we just want to see who's going to pass out walking from the van to the cafeteria. And while during lunch, we watched a video narrated by a famous astronomer you might have heard of, Johnny Carson. Did the narration, the history of the summit. But as I say, a little more difficult to get up here now because of the protests. I mentioned the Subaru, the Japanese National Telescope. There it is on the summit. It's the same Subaru that's depicted on the front of your car, you know, the Subaru. Now there's a little confusion because there's only 6 stars on the insignia plate of a Subaru. The group Subaru is called the 7 Sisters. So for astronomers, they know there are actually 7 bright stars visible. If you have good vision, you can see them without optical aid. But only 6 of them are really visible, and that's what Subaru grabbed. The 6th one is a little less visible. And the Greeks called it Pleiades. So this is a typical view of Mauna Kea, where you can go skiing. I don't know how accessible skiing is right now because of the protest camp, but it's a world center for astronomy. So we've been at it for an hour. Let's take a break. Pam may have some announcements.
Do you want them right now?
Sure.
Yeah.
We have everybody. Oh, sorry, I should have given you some more. That's typical.
It's okay. The spring catalogs are posted online and available at the Ollie office. And they went live on the 17th, which was Monday. Midday morsels today from 11:45 to 12:45 at First Universalist Church. Please come hear Maggie Farley speak on Beware of Fake News. Maggie is a former foreign correspondent for the Los Angeles Times and is now at Google News. This is an important and interesting topic, especially during this election season. And Opera Colorado artists and residents will be joining Robert Montgomery and Mo Matthews at Viva la Opera class on Tuesday, March 3rd, from 9:30 to 11:30 at Park Hill United Methodist. Please join us for this terrific performance. This is open to all OLLI members and guests, and it's their last Tuesday class for that. That's all.
Okay, so if anybody has ambition to go to the event,
The fake news.
the fake news lecture, go right ahead and go. I won't be offended. I mean, I'm not the only one talking today, so, and they have food, and we know not.
No.
Oh, they don't have food.
You can eat your lunch during the lecture.
Oh, okay.
Get your food.
Eat your own food.
Bring your own food. BYO lunch.
All right, so we'll have a break now. Steve?
In the topic of shameless self-promotion, I'm doing a class, leading a class in the spring about birds. It's not bird watching, it's bird physiology and anatomy. And several people here have taken the class. This is the 4th time I've done it. And it's a lot of fun and not nearly as mind-bending as what Dr. Friedman is telling us.
Yeah, the class
Okay.
is outstanding.
It's a fabulous club.
Well, now, when's the first day of class for the spring session?
March 30th? I think?
Yes, yeah.
Okay.
Where is that class?
Pull that out.
It's at First Universalist Church, Hampton and Colorado Boulevard.
Do you know when they have the first floor assignment?
I think February 28th.
So Ed,
Yeah.
Mauna Kea used to have the tours, right, in the afternoon, in the evening, that you could go up and see? Was
Oh,
that-
I don't know about that.
I have to look, or was it Mauna Loa?
They give you a.
Mauna Loa has a research lab related to measuring atmospheric conditions, aeronomy lab. I don't know how
I
it's.
thought they were putting that new telescope on Mauna Loa, and that's where the problem was. They're putting it up with all the other
They
ones.
want to.
Right.
And what I didn't mention is there's a judge who was involved. Everybody's been involved, the governor of the state and so on.
Right.
The judge said, I have a plan. You could put your big telescope up there, but you have to take another telescope down. And the astronomers and the governor agreed to that,
Tries to do it.
but the
It's a fun
native
topic.
community did
It's,
not. They don't want
just
any
about
more
everything
construction on
related
this
to
summer.
Bird's construction
And
is
so,
tied to its.
actually
ability to fly.
Keck, which is in the middle of the picture there, I think Keck's ambition to put smaller telescopes to build an interferometer, I think that died.
Bladders.
So,
So we went over there,
As
like
an
in
as
like
an impact for some birds on flight.
2012 maybe, or 13. And
Birds,
we
secrets of
canceled
flight
our
and
tour.
behavior.
They had evening tours. We
Wednesday
could go up and
mornings.
do stargazing.
wow,
And
I didn't know.
2 of the 4 in our party said, nah, let's not
Ah.
go. And the other, myself and my son were like, oh, but it'd be so much fun. And my husband said, it's too much money. And now I'm kicking myself. 'Cause you
Well,
can't get
here's
up
the
there.
thing, if you want to do stargazing, I don't know if you meant just stand outside and look at the stars or see what the telescopes are seeing.
I think it was a little bit.
There's no reason to go to the summit, because if you go to the control facility for Keck is down on the beach.
Oh, okay. Yeah, oh,
You
no,
can
we
go,
had
oh, it's
beautiful.
at Hilo,
Okay.
and you can go to Hilo, which is, bring an umbrella, it's the rainiest place on the planet.
Oh, wow.
Yeah, it's,
Hilo's the one that's over near Volcano National
yes,
Park, right?
yes, southeast corner.
Yeah.
Oh, there's so many stories about this where they have workers going up, they give people assignments, because you're above 13,000 feet.
Yeah.
So they send people up and they give them warning about, altitude and stuff. Only a small group of people are allowed to stay at the summit, because it has an adverse impact on your health.
Yeah.
And one story I heard is they sent the welder up there. He's supposed to take this big sheet of metal and put it over some kind of hole or something they wanted to seal up and weld it there. And he called it. He was gone for like 4 or 5 hours. And he called it, he said, this piece of metal you gave us is too small. And I keep cutting it, and it still doesn't fit. He decided it didn't fit, so instead of positioning it properly, he took his welding torch and he cut a piece off of it, which made it smaller. And then he called and complained, it's too small, I'm gonna cut it again. And they said, do you see the green bottle in the corner of the room little green bottle this tall. And there's a mask.
Oh, wow.
Get some
Oh.
oxygen, dude, and use the oxygen until you descend to the dormitory, which is at 9,000 feet.
Right.
Ironically, they've had, when they built Subaru, Subaru, 2 workers were killed in a fire. It's very hard to create a fire at that altitude, but they were in a closed space and there was a fire and 2 guys died building Subaru. There's just endless stories. The human efficiency at that altitude without oxygen is the same as astronauts. Everything happens slower, people make more mistakes. That's why they have the astronomer team is down on the beach.
Did you make all the slides that you were showing us?
Oh, I stole everything.
Well, but some of them have animations where circles and arrows.
Oh,
and
that I
stuff.
did. Yeah, that I did. And you'll see personal photographs of my tour of the summit.
It was really cool.
Did you have a question or comment?
Oh, I was just gonna say, I've been reading Tyson's book about astrophysics for people in a
Yep.
hurry. That's entertaining.
And there's a companion book he wrote for kids. I don't know if you have grandkids or younger people in your family. It's like astrophysics for people in their teenagers and words like that.
There was.
Yeah, he's a very entertaining character. I know him, and I have, every time my wife and I go to New York, I call his office and I say, my wife's a huge fan of Neil's. Can she come in, just get a sample picture, and then we'll leave? And it's always, and now it's impossible because he has blown up as a celebrity.
And then that next.
He's never there. He's at the Museum of Natural History, the American Museum of Natural History. And he's the director of the planetarium.
I've heard that, or I've seen some.
Yeah, and
I
he's,
know. But
he's
I
a great
often
guy to
see
talk
with
to.
these kind of
you know,
things.
he's
I often get talked.
got a great attitude about science. We saw him, he was in Denver a couple of years ago at Paramount, giving a lecture, and it was like going to a rock concert. People were freaking out. He
Yeah.
was-
One other question, is that
Yeah.
Sophia telescope in the 747, is that a second heaven?
It's a monolith
Uh-huh.
built by the Germans.
For this one.
The German space agency built that telescope assembly, and it's under attack right now. The new president, I'm going to talk about this a little bit. The proposed budget is not good for
So
science.
then the next day, they like.
Flying that airplane, so they might.
Yeah, well, it's a
We
big
did, we
problem.
saw it.
They
Did
say
you
this-
actually knew the scientists who flew?
No, the crew. The crew
Oh,
of the
right,
747.
right.
He's
Too bad, I
Yeah.
mean, that's
Good.
been a good
Yeah,
job.
I think it's going to be shut
Yeah.
down.
No, we did get the money back.
Or at least that's what the budget was. All right.
They said all of the
So-
crew or the scientists in the back all speak German.
Yeah, right. Yeah.
In the picture of the telescope, you had the mirror, you had the hole in the center, and then there's sort of a blob
New York City, same
to
thing.
the side.
Multiple lasers to focus on a single object.
But when I went to
Yeah,
the-
no,
Let's go on top.
this,
Because I went to.
Oh, that's a mirror that turns the beam. If they put the structure in where that is, we can be
No,
able to
well,
see.
that was one.
That's the
Oh, what was
tertiary.
before
That's the
that?
third
A
mirror.
fair
To get the light into this
oh,
black.
I thought it was on the,
Oh, I
this.
did, I.
but
No,
it's
no,
not.
no.
Okay.
Yeah.
There's nothing on the mirror. The mirror, when you look at the mirror, you can't see it. It's so perfect. All you see is the room above you. All right, let's resume because we've got lots more to talk about. Subaru. Oh yeah, so here's a picture of the protest camp.
So I think you can still go up on these stargazing tours.
I don't know.
Well, it still has a site for it,
Okay, well,
but that'd be.
so if you're gonna be on the Big Island, you might consider this, just, once again, check with your rental car company, because this is called a saddle road that crosses the island, and you're strictly forbidden from driving on the saddle road. Anyway, that's
Wayne Johnson?
Dwayne Johnson or Jason Momoa. I think that's Dwayne Johnson, but Jason Momoa, the actor, is also involved in protesting the telescope.